In this session, we're going to see how to solve basic exponential equations. The ones I'm calling basic are of the type 5 to the x equals 5 to the negative 6, or like 5 to the x plus 3 is equal to 1/5. The name of the game here, if we possibly can, is going to be to make the bases match. The reason for this is that if you recall the graph of an exponential function, they are one-to-one functions, which means if two results are the same, the exponents must be the same. So to solve 5 to the x is equal to 5 to the negative 6, we just note that the exponents must be equal, and so x is equal to negative 6. Yep, it's that straightforward. Of course, they get more interesting. Here's the deal. The equations get more interesting. Down the road, there's going to be another video solving more interesting exponential equations. You're going to forget this. On a test, you're going to forget this. Don't. Just, if you can make the bases match, do so. That leads us to the next example. 5 to the x plus 3 is equal to 1/5. What I want to do is envision both sides as having the same base, making bases match. It seems to me that 5 would be an appropriate base in this case, and so I'm going to write the left-hand side the same, 5 to the x plus 3. The right-hand side, I'm going to write it as 5 with an exponent. 1/5 is 5 to the negative 1. Therefore, I have the bases matching, and so it must be the case that the exponents match. In other words, if 5 to the x plus 3 is equal to 5 to the negative 1, then x plus 3 must equal negative 1, and so x must equal negative 4. And as you may recall, any number can be an exponent, and so the answers that we get for these ones are going to be good and solid. You could check this by putting it into, say, a calculator or just using your properties of exponents to check. It works. Next, we have 8 to the negative x plus 14 is equal to 16 to the x. I don't see matching bases. However, I see a common base. 8 can be expressed as having a base of 2. And in fact, 8 is 2 cubed. And so, 8 to the negative x plus 14 could be rewritten as 2 cubed to the negative x plus 14. On the right-hand side, I see 16 to the x, but 16 could be written as 2 to the 4th power. So 16 to the x is 2 to the 4th to the x. And now what I have is a situation where my bases match. I have matching 2's. But now I need to use properties of exponents. Whenever we take a power to a power, we're going to multiply the exponents. On the left-hand side, that means we're going to distribute the 3 to the binomial exponent. So we have 2 to the negative 3x plus 42 after distributing 3 into the negative x plus 14. On the right-hand side, we have 2 to the 4 times x, and that's simply 4x. Now that the bases match, I want to make an equation of the exponents. And so what this will imply to us is that negative 3x plus 42 is equal to 4x. Now I have this linear equation to solve, and I can do so by, say, adding 3x to both sides, so 42 is equal to 7x, and then dividing by 7 gives me that x is equal to 6. You could double check that x equals 6 is a legitimate solution by substituting 6 in place of x in the original equation. I leave that to you. Next, we're looking at 3 to the x is equal to 81. I see on the left-hand side the base is 3. On the right-hand side, I see that 81 can be written as 3 to a power. In fact, 81 is 3 to the 4th power. Back to the left-hand side, 3 to the x, whenever we see a power to a power, we multiply those exponents. And remember that x times x is not 2x, but is x squared. So if 3 to the x squared, yeah, you can put an exponent on an exponent, but you didn't know that. If 3 to the x squared is equal to 3 to the fourth, then that will imply, since the results are equal and the bases match, the exponents must be equal. X squared is equal to 4. And so we see when we can make the bases match, we end up with equations that are fairly straightforward in solving them. If x squared is equal to 4, then x is equal to 2. And remember, whenever we square root both sides of an equation, we have to remember plus or minus. I hesitated there to see if you would remember that. Remember, any number can be an exponent, and so the answers are x equals plus or minus 2. Moving on, they get somewhat more interesting here, but the name of the game here for this entire session is to make the bases match. Here we have 2 to the x times 8 is equal to 4 to the x minus 3. I want to be able to write everything with a base that matches, and 2 looks like a good candidate here. 2 to the x, can we write 8 as 2 to some power? The answer is yes, it's 2 cubed. And so this equation becomes 2 to the x times 2 cubed is equal to, on the right hand side we have 4 to the x minus 3. That 4 can be written as 2 squared. So 4 to the x minus 3 becomes 2 squared to the x minus 3. And now we're looking at properties of exponents. On the left-hand side, 2 to the x times 2 cubed. The base is going to be 2, and whenever we're multiplying two numbers with the same base, you remember we add their exponents. And so 2 to the x times 2 cubed becomes 2 to the x plus 3. On the right-hand side, we have a power to a power. And so we're going to multiply those exponents. 2 squared to the x minus 3 becomes 2 to the 2x minus 6. Now, since my bases match and the results are equal, it must be that the exponents are equal. And so we end up with the equation x plus 3 is equal to 2x minus 6. This is just a linear equation which can be solved by subtraction and addition. I end up with x is equal to 9. I encourage you to double check and make sure that it works. I'm going to move on. Next we have e cubed to the x is equal to e squared times e to the x. I see that we have a common base, e. Well, when it's e, it's easy to see, isn't it? On the left-hand side, we have e cubed to the x. We're going to multiply those exponents. So we have e to the 3x is equal to, on the right-hand side, we're multiplying two factors that have the same base, and so we're going to add their exponents. And so e squared times e to the x gives us e to the 2 plus x. Now that I have matching bases, it must be that the exponents are equal, since the results are equal. And so we have 3 to the x is equal to 2 plus x, and that implies that 2x is equal to 2, and so x is equal to 1. Last, but by no means least, we have 4/9 to the x plus 8/27 to the 1 minus x is equal to 2/3. If we look closely, that 4/9 could be written as having a base of 2/3. Since 4/9 is 2/3 squared, I'm going to write that. And since we have 4/9 to the x, we actually have 2/3 squared to the x. 8/27 likewise can be written as having a base of 2/3. 8/27 is going to be 2/3 cubed. So 8/27 to the 1 minus x is going to be 2/3 cubed to the 1 minus x. On the right-hand side, we simply have 2/3, and now I can see it was a good choice to go with 2/3. Back to the left-hand side. When we have 2/3 squared to the x, we're going to multiply those exponents. We're going to end up with 2/3 to the 2x. For the 2/3 cubed to the 1 minus x, we are going to distribute, because that 1 minus x is a binomial. We end up with 2/3 to the 3 minus 3x once we distribute that exponent. And that equals the right-hand side 2/3. Now back to the left, we have two factors that we're multiplying together. They have the same base. So we're going to consolidate that, write down 2/3 once, and now remember we're going to add the exponents. I'll take this step by step. So we have 2x from the first factor plus 3 minus 3x from the second factor. You see we are adding those exponents together. And on the right-hand side, we still have 2/3. Collecting like terms in the exponent now, we have 2/3 to the negative x plus 3. I went ahead and put that in descending order because it's just one of my habits. On the right-hand side, that equals 2/3, and I'm going to write something just to make it really explicit. This is 2/3 to the 1. And I only do that so that we can see that since I have matching bases and results that match, the exponents must be equal. So I can write down that negative x plus 3 is equal to 1. Fast forward just a touch, and so x is equal to 2. So as I said, when we get to the more interesting equations and learn other techniques, for some reason, you may be tempted to forget these basic ones and just apply the new techniques, which just makes things harder. So if at all possible, make the bases match, and that's the point of this session.